Good morning, everybody. It's Miss Bailey, and I'm here with Yoda. Yoda's reading his James and the Giant Peach book, but he's also going to be watching a Brain Pop video with us and then kind of paying attention to the activity that we do on circuits. So, what we're going to be doing today, this is going to be a science lesson on circuits. We're going to watch a Brain Pop video, and then we're going to complete a couple of quick notes and drawings. We're talking about open circuits, closed circuits, parallel circuits, and series circuits. So those are the four types of circuits that we'll be talking about and drawing today. And this should be pretty quick and easy. So I'm going to start the movie, and Yoda and I will be down here watching it with you. Let me make this full screen. Turn up the volume.
Hey, don't stay plugged in too long. Mom said our electric bill was really nuts last month. Dear Tim and Moby, what is an electric circuit made of? From Joseph P. A circuit is a way of routing electricity along a path. Electricity happens when electrons, the negatively charged particles in an atom, move from one place to another. Electricity is nearly instant in the natural world. Think of a bolt of lightning or when you get a shock from touching someone. Right, those are examples of static electricity. It's actually not all that useful as a power source because all the energy is released all at once. Ow. In order for electricity to be useful, we need a steady flow of it, a current. An electric current doesn't just happen on its own. It needs a path to follow. And that's what a circuit is, a path that a current can flow along. Well, yeah, but you need more than just a wire. Even the most basic circuit is made up of a few different components. First, there's a power source, like an outlet in the wall or a battery. The power source provides a steady supply of electrons. In the battery, the electrons come from the negative terminal. From a wall outlet, electrons come from the shorter of the two slots, called the hot slot. The electrons need a path made of a good conductor, which is any material that allows electrons to move through it easily. Most metals make good conductors, so we use metal wires as a path in electric circuits. Yeah, the wires are surrounded by rubber or plastic because those materials are good insulators. Insulators are kind of the opposite of conductors. They're materials that electrons have a hard time flowing through. Insulated wires keep electrons on course, and they protect us from the dangerous flow of electricity going through their metal cores. Along the circuit's path, there's usually a load, a device that uses electricity. Electrons flow through the device, giving it power. When they flow out of the device, they head towards the opposite side of the power source. In a battery, that's the positive terminal. In a wall outlet, that's the taller of the two slots, the neutral slot. And that's the real key to an electric circuit. The electrons have to have some place to go. Without a somewhere to flow into, the electrons will stop moving and you no longer have a current. If you look closely at an electric cord, you'll see that it's actually two separate insulated wires. Electrons flow out of the hot slot, down one of the wires, into the load, through the wire on the other half of the cable, and back into the neutral slot. Oh, right. Well, to control whether an electric device is on or off, you need a switch. A switch controls the flow of electrons by opening and closing a circuit. When a switch is in the off position, the circuit is open. And when it's in the on position, the circuit is closed and the electrons can flow through. Whoa. I think you've had enough. Uh-oh. Well, now you've gone and done it. Oops is right.
Okay, guys, so that was our little Brain Pop video, but I think Tim and Moby did a good job of explaining electrical circuits. So we know that electricity needs a path to flow along, and that path is called a current. And then the circuit is when there is a complete path for the electricity to flow. So we're talking about current is the flow of electricity, and then the circuit is just a path for it to flow along. And it has to make sort of a complete loop. It has to have somewhere to flow, otherwise it's not going to continue flowing. All right, so now we're going to draw a couple of different types of circuits. So I'm going to bring up my document and bring it back to the beginning. All right, so they talked about sources of electricity, and I'm sure you guys have around your homes power outlets where you can plug something in. And remember, electricity is just the flow of electrons, which have a negative charge. So, and it's a source of energy, so we can use it to power different things around our house. So in your house, you have an outlet where you can plug into the outlet to receive the electrical energy to power different things. But then sometimes if we are moving around and we need to go outside or go somewhere else, we can use batteries when there's not a convenient plug around. So batteries are a portable source of electrical energy. And batteries have a negative and a positive side. So we said that electrons flow from the negative side to the positive side. That's how electricity flows. Out the negative and then into the positive. So we're going to label our negative and positive on the battery. And they're often called terminals. So this is my negative. So we use just a minus to label the negative. And quite often the battery is marked and it'll show you a minus for negative and a plus for positive. And then this is my positive over here. Positive terminal. Okay. And so if we had wires, we know wires are usually made of metal because they are good conductors, but they are often insulated with rubber because insulators protect us from absorbing some of that electrical current. So you can touch the rubber part, but then the metal part actually has electricity, the current flowing through. So there's Luna. All right, so if we had a wire, the current's going to come out the negative part of the battery. And if we had some sort of load, like a light bulb or something else we were trying to power, it would be attached along that wire. And then it's going to flow into the positive terminal of the battery. So I'm going to draw arrows to show. Remember, the electrons have a negative charge, and it's flowing this way. And what's coming out is the electrons. They have a negative charge. All right. And it's flowing around and around and around. Okay. And these are negative electrons. They come out the negative end and return to the positive end or terminal. Okay. So we're going to write that here. Right here we're going to write, and I'll use a different color so it stands out a little bit better. Electrons that's an E. Okay, electrons flow from the negative end of batteries. So I'm going to write that, negative. And so when you complete your notes and your drawings, which you should be completing either with me or after, you can post those completed notes on Seesaw, or you can post them on the Google Classroom. But all of the videos have activities attached to them, so you should be completing those and then sending your completed work back. Okay, so electrons flow from the negative terminal of a battery and then make a complete circuit and return to the positive terminal. All right. And that's an E, so it's electrons, ElectronS. Right, I'm going to erase that and scroll down. Oh, wait, other battery. Okay. So again, this is a different type of battery. It's a AA battery, but the terminals are marked negative and positive. But the electrons are going to flow out of the negative end of a terminal, make a complete circuit, and back into the positive end. Okay, so this is my negative end. This is my positive terminal. And they come out this way. So I'm going to draw little arrows. Okay, and the arrows are just showing which way the electrical current is flowing. So it's coming out the negative end, going around, coming in the positive end, back out the negative end, around. And that's how, if we had some sort of load like a light bulb hooked up to this, it's going to keep the light bulb continuously burning because it's continuously flowing and making that loop or circuit. All right, and remember, negative electrons are flowing through the wire, down the wire. Okay. All right, so that's our batteries, just a portable source of electrical energy. We can move them around and take them where we need to go. All right, so I'm going to erase that and scroll down. And the first type of circuit we're going to talk about is just a closed circuit. So we know for a light bulb or any type of appliance or anything that we're going to power with electricity, we have to have a closed circuit, meaning it's making a complete loop. So again, it's going to come out my negative terminal, the electrons, and it's going to go to my light bulb or whatever type of load I'm trying to power. And then it's going to come back around to my positive terminal. All right, so I'm going to label these. This is my negative. This is my positive. And the same idea happens when you're plugging a plug into your wall outlet. In the video, they showed us how there's a negative and positive slots on your plug, and two different wires that one is bringing the negative charge into whatever you're trying to power, and then the other wire is bringing the charge back to the circuit. Okay. All right. So we're just going to show our arrows again, coming out of my battery, the negative terminal, going to my light bulb, and then it's got to make a complete return to the other terminal of the battery. If we just hooked up one end to the light bulb, it's not going to power the light bulb. Okay. So again, we have our negative electrons flowing, Okay. And this, because it makes a complete loop or circuit, is called a closed circuit. So there are no breaks in the flow of electricity or the current, and the battery makes a complete loop to the light bulb and then back to the battery with a continuous flow. So that's called a closed circuit. Right. So you guys can draw that. Okay, so if we have closed circuits, well, the opposite of that is open. So now we're going to draw an open circuit. And still the electricity is flowing from the negative terminal. Let's say we have a switch. If you're a good drawer, I'm sure you can draw a much better switch than that. But I am going to just write a switch so we know what that is. It may not be obvious by my drawing. So here's my switch. And if you notice, there's a break right there. So when the switch is in the off position, and maybe I'll write that underneath. When the switch is off, it's going to put a break in the circuit. So it does not make a complete loop. You can see there's a break right there. And then still my wires are returning to the positive end of the battery terminal. But because there's that break there where the switch is off, and so it's not making a complete loop or a complete circuit, this is called an open circuit, and the light bulb then would not light up. It wouldn't work. But again, my electrons are still flowing this way. Well, actually, let me erase that. Because with that break, they're actually not going to be flowing to complete the circuit. So they're never going to make it to the light bulb. So they might come out here, but just die. Okay, so there's a break here in my circuit. And so the electrons are not going to be able to make it to my light bulb. And they're not going to be able to return to the battery. And so battery does not light up. All right, so this is going to be called it's not going to. Okay, this is an open circuit. No, it's not going to work. Okay. Let me just erase it. Okay, so my open circuit, though, we have a break in the flow of electricity, and so it's not completing the circuit. Okay. All right, I'm just totally messing that up. Okay. Much better. All right, so now we finished our open circuit. We have a switch here. The switch is in the off position, and you can see that the wires, there's not a complete circuit there. And that's why we call it open, because there's an opening there in the loop. All right, so we'll erase that one. All right, the next type of circuit we're going to talk about is a parallel circuit. Okay. So I'm going to write that up here. Parallel. We talked about parallel lines. So this is kind of a similar concept. So once again, we have a battery. We've got two light bulbs, and they're being powered by the same battery. So in a parallel circuit, each light bulb, or whatever the load is that you're trying to power, has its own circuit to the power source. Okay. So, and again, here's my negative terminal, positive terminal. And you can see one wire has connected this light bulb to the battery, and then another wire has connected this light bulb. And so in a parallel circuit, if this particular light bulb, let's just say there was a break here. Maybe the wire came loose or something happened where this light bulb is not working. This one will still be able to work because it has its own connection to the power source. So that's a parallel circuit, meaning that if this one, if this one goes out, this one can continue to still work. Okay. So parallel circuit, both light bulbs have their own connection to the power source, and both of them, can work separately. There's not a flow from one light bulb to the other. This one has its direct connection, and this one has its direct connection, but there's not a connection between these two bulbs. Okay. I should have Larry explain this. He could probably explain it a lot better. But so while my electrons are flowing out of the negative end, they're coming to this light bulb and coming to this light bulb in two separate circuits. All right, so that's my parallel circuit. Clear that one out. And then the last one we're going to talk about is a series circuit. And so you should have noticed that the light bulbs are arranged a little bit differently in relationship to each other. This is called a series circuit. All right, so once again, my electrons will come out my negative end of the battery. They're going to come around to light bulb number 1. Then they're going to continue on to light bulb number 2. And then they're going to come back around to my positive end of my terminal. Okay, so this is negative. This is positive. Okay, so in a series circuit, the circuit is one continuous loop, but each light bulb does not have its own connection to the battery. So if for any reason let's just say there was a break right here. If this light bulb is not being lit, then this one will also not be lit because they don't have their own connection to the power source. Okay, so in a series circuit, it's one continuous loop. You might have more than one load, more than one light bulb or whatever you're trying to power on the circuit. But if there's any break along the circuit, then that means that the entire circuit is not working, and so whatever's along that circuit is not going to be powered. Okay, so this is called a series, where the light bulbs or loads or whatever's being powered is in a consecutive series, one after the other on the same loop. Okay, series circuit. All right, so that's all that we're going to talk about for science today. Just remember, you can rewatch the video on your own if you want to on BrainPop, and then you're going to complete the activity. And then you should be sending that back, either posting on Seesaw or onto the Google Classroom. I'm also going to be posting today some James and the Giant Peach questions, so make sure you're continuing to read on that. Okay? All right. Bye, everybody. I'll see you soon. Have a good day.